I'm Sneha from the Web3 Compass, and this is day 23 of 30 days building with Solidity. It's just one more week to go before we wrap up the campaign, and we can't just believe how far we have come. So many of you have joined us in the process. We have more than 150 people in the community. So many of you have stayed consistent, coding every day, writing content every day, and a big shout out to all of you guys. For those who have joined us recently, don't worry, the challenge still stays. And you can always ask questions in the community, blah, blah, blah. For those who still don't know what this campaign is about, you can go to my day one video. That is where I talk about the entire campaign in detail. Or you can head over to web3compass.xyz and you can find everything on the website. We also have some really cool stuff on the website, like some beginner courses, a play section where you can play games, like 2 games, I think. One is a challenge. And then there's Explore, where you can explore the communities in your city, also add communities and all of that. Yeah, that's pretty much it. So today we're going to enter the DeFi world, and we're going to write a Lendingpool Contract where we're basically building a system for lending and borrowing digital assets. You will learn how to calculate interest and manage collateral, demonstrating core DeFi concepts, and more like a digital bank for crypto, showing how to create lending and borrowing platforms. So let's just get started. Okay, so I'm here on Remix and I will create a file which says simple lending dots. All okay, zoom in. Yeah, this should be fine, right? So today, while we get into building a bank, not the kind that has long queues, paperwork, and hidden fees, not the kind that closes at 5 p.m. exactly and has long lunch break hours. We're talking about DeFi, which is short for decentralized finance, and it's not just a buzzword. DeFi is one of the most game-changing movements in the blockchain space. It's about rebuilding the entire financial system, lending, borrowing, saving, trading, doing it without centralized institutions and having any middlemen involved. So you just code open, transparent, and unstoppable code that anyone can interact with. That's what really makes DeFi so powerful. So you take the rules of traditional finance, turn them into smart contract logic, and let blockchain do the rest, right? And as we know that smart contracts are immutable. Once you have deployed the contract, doesn't care who you are. If the numbers add, you can lend, you can borrow, you can earn interest. So yeah, that's what we're building today. A mini version of what platforms like Aave or Compound offer, but way easier to understand. You can obviously get into the more complicated sections and all of that. But today we're going to look into accepting Ether, a deposit from users, let them lock collateral to unlock borrowing, charge interest over time, let users repay loans and withdraw their funds. And this is your first hands-on taste of DeFi mechanics, and trust me, it's going to change how you see smart contracts forever. DeFi seems a little overwhelming at the start, but then you can always deep dive, take some time to understand what happens, look into Uniswap, Aave, and how these things are working, and then yeah, you can get better at it day by day. So we have written the basic structure. Now we will get into the mappings, the state variables, and all of that. So let's just get to coding. It says contract, simple lending. Okay. Now, what are the kind of mappings that you're looking at, right? Obviously, there would be a deposit balance, there would be borrow balances, there would be collateral balances, there would be last interest, timestamp, and all of that. And there would be certain constant points like interest, collateral factor, and all of that. Here we're not looking at who the owner is, who is not, just getting started with the entire thing, right? So let's just write it. We're saying mapping. If it's my wallet address, there should be a mapping with uint 256, not 356, 256, and then make it public. And then we say, hey, that is deposit balances, right? And we just copy this, save some time, again another mapping, again another mapping, again another mapping, right? Again, format it. Okay. So this would now be borrow balances, like how much have I actually borrowed? Then this could be collateral balances, like how much have I added as a collateral? And then this will be the timestamp, like what was the last timestamp when I performed a particular step. Oh, probably related to the interest, like when was it charged, or when did we pay it off, or whatever. So then, these variables are explainable. Deposit balances would be your digital vault, which is basically keeping a track of how much ETH the user has deposited in the lending pool, and you will use the deposit function for it, which we will write later. The borrow balance would be your loan ledger, right? That mapping would show how much ETH a user has borrowed from the pool. Again, this would work when we write the borrow function and the user calls it. The ETH will leave the contract and comes to your wallet. At the same time, the mapping gets, updated to track exactly how much debt you owe. With collateral balances, it's like the safety net. So in DeFi, obviously borrowing isn't trust based. It's very math based. So to take a loan, you need to lock up some collateral. That's even there in the real world, that if you are like taking some loan, there has to be some collateral angle there. So this mapping will basically keep a track of how much ETH the user has provided as a collateral, and there would be like a deposit collateral and collateral. There would be a deposit collateral function, and then, it will keep track and ETH stays in the contract, but then your collateral balances entry will increase. So when you sort of borrow or withdraw collateral, the contract will use this mapping to check if your position is still safe. And you can just think of it like a security deposit to protect the system if you don't pay your dues, right? And the last interest accrual timestamp is again your timekeeper. So the interest in our system doesn't accumulate automatically every second. This would be too gas intensive. That is why we record the last time we calculated interest for each user. Then whenever the user interacts with the system, be it borrow, repay, etc., we check how much time has passed and calculate how much interest has built up since then. So this will let us simulate continuous interest without paying for it, for every block and making it extremely gas heavy. Now let's just get to the lending logic. Like, we'll have to set up a few things like what is the interest rate, what is the collateral basic point that we're going to look at, right? So we'll say, hey, uint 256 public, and then we're saying interest rate basis points. Okay, so here with this, we say that this is basically the interest rate that borrowers will pay annually on their loan. But instead of writing 5 for 5%, we write 500 because we're using basis points here. Basis points are basically used in finance to express percentages precisely, especially when dealing with fractional rates. Like 1 basis point is 0.01%. So 500 basis points is 500. Right? So we're saying it's 500. Similarly, uint 256 public collateral factor basis points. Now, what is this? Like, how much, of the percentage of collateral you can actually borrow? So we're setting it as 75%. So it's 75% loan to value. That means if users can borrow only up to 75% of the ETH that they lock in as a collateral, let's say you deposit 2 ETH as collateral, then 75% of 2 ETH is 1.5 ETH. That's the maximum amount that you're allowed to borrow. Now, some of you might be thinking that why can we not borrow 100%? Because price volatility exists. ETH might drop in value tomorrow. So we always want borrowers to leave a safety cushion. That's what the collateral factor enforces. So in real worlds, it's like the bank saying, hey, we loan you money against your car, but only up to 75% of its current value. So this helps the protocol avoid losses and ensures that borrowers always have enough collateral to back their loans up. Okay. Now, we will write certain events. I think we'll have quite a few events here. So then, okay, we know that once a deposit happens, that should be an event. So we're saying address, indexed, a user, what else? Uint 256 amount, right? Now, the same would go for withdraw. Okay. Withdraw, the same would go for borrow, right? And then same would go for repay. Okay. Now, a similar kind would be for maybe collateral deposited and collateral withdrawn. All of these will just need the user address and the amount that you're borrowed, right? So we're saying withdraw. Okay. Oh, it's wrong. Yeah. Then we're saying borrow. Okay. Again, borrow is user, what amount did they borrow? Then we're saying repay. Okay, great. Because the person wants to repay. Now, collateral deposited because that person is going to, deposit the collateral as well. Great. And then collateral withdrawn, right? That's all I can think of in terms of, you can make it extremely event heavy. But I think these are the main ones that we would need. Okay. Okay, so now that we've written all the events, we should just head straight to writing our function, cute little functions all together. So let's start with deposit. Now, we will deal with money here. So this has to be not eternal, external, payable. Yeah. Okay, so obviously you will check a condition here. You know what I am thinking, right? Message value greater than 0. If yes, great. Otherwise, ETH value should be more than 0, right? That's what you will check. Then what you would do is take the deposit balances mapping for the message.sender and then do a plus equals to message dot value. Great. Now the mapping is updated. And then you will just emit deposit, right? The user would be the message.sender and the amount would be message.value. Wow, how cute was that, right? Now everything here is self-understandable. So we will just quickly go to function withdraw. Okay. Now, can you think of what would we need here, right? Say, okay, we have to withdraw a certain amount, and let us give that as the parameter, right? Again, let's make it external, and we're saying require first the amount has to be greater than 0. If yes, great. Must withdraw more than 0, right? That is one condition. Again, require, we will check if the particular message.sender has enough balance. So we say deposit balances, message.sender is greater than amount. Otherwise, it should be insufficient balance because whatever you're trying to withdraw, you do not have enough money for that. Now, this shall just deposit balances, message.sender minus equals to amount. And the AI says, let's just cancel this. Okay. The once you've deducted the amount, great. But it says emit withdraw. No, you have deposited it, but did you transfer it? You haven't. So we will say, hey, this particular message.sender has to be payable, and we say payable message.sender dot transfer amount. Okay, and then emit the amount here. Okay, so great. This was pretty much clear. Like you did the validation for the withdrawal request. You checked if the person had enough amount. You updated the balance. Now you're sending the ETH back, right? Because that's, that is where the transfer is happening. And you have to remember that Solidity requires dot transfer to be called on a payable interest. That is why we cast message or sender to payable, be so whosoever is the user. Okay. And then we're broadcasting the event. That's it. Okay. Now we will go to writing a function which is around calculating interest. So we're saying function calculate interest. Or now, who are we calculating this interest for? Again, it's for a user, right? So we're saying user. Now we just have to return it. So we say public view returns, and it has to be uint 256, right? Because that's what the value we need. Now we'll check a condition which says, hey, what is the borrow balances for the particular user? If it is equals to 0, then you know what, just do one thing, return 0, because there's no interest, right? Else what you have to do is you would say uint, why am I writing some random numbers? So we're saying for time elapsed, right? We need to calculate. So we say log.timestamp minus the last interest accrual timestamp of the user. And for calculating the interest, uint 256, we will say interest is equals to, now we have put 5% as the rate. So we will say borrow balances of that particular user, okay, into interest rate basis points, which is 500, okay, into time elapsed. Okay, great. Now we close this and then we divide it by 3. Now, how is this interest calculation actually happening? Okay, so everything as of now should be clear to you that, okay, interest, borrow balance, great, whatever you've borrowed, your interest rate basis points is 5%, time elapsed is this much time. Now, you know that the basis points is again on like certain percentage. Our annual interest rate is like 5%. So with this 10,000 into 365 days, we're basically using it to convert basis points into an yearly fraction. So this gives us the interest accrued so far, because we're not talking about annual interest here. We are just calculating it on the basis of whatever time elapsed has happened. And that is how, we do the entire calculation. So I hope that's clear. And once we've done that, we will just say return, return borrow balances of the user plus interest. Okay, so now this entire thing must be clear that this is the total debt that is happening, principal plus interest. So just like that, you have like an up-to-date debt, no manual math is needed. The total is what we use in all other functions to verify borrowing eligibility, check repayment amounts, and validate collaterals, etc. Now we will go on to writing another function, which would be deposit collateral. Again, very cute little function here. Deposit collateral. Okay. Not taking here, we're saying external, great, payable, again, same conditions. I'll just copy it from here, right? So we say, Okay, required message dot value greater than 0. That means must deposit a positive value as collateral. Instead of deposit balances, we will change the mapping to collateral balances, right? And we say of the particular message dot sender, you add the value. And now for deposit, we just add collateral deposited. That's it. Yeah, that's it. That's all that you had to do. So far you have seen how to deposit ETH into the pool as a lender. That's great if you want to earn passive income. But what if you want to borrow from the pool instead, right? Well, just like that in real life, if you want to take a loan, you need to put something down. And that is what we mean when we say collateral. So now, collateral versus deposit, if you want to understand what the difference is. So deposit is the money that you lend to the pool. Collateral is the money that you're locking to borrow some amount instead. So deposits can be withdrawn freely, like unless, you've borrowed it against something, and only returned if your loan is safe. So collateral will only be returned if your loan is safe, and deposit is something that you earn interest on. So if the system supports that, collateral is something that backs your borrowing or loan and keeps the protocol safe. So yes, both of them are ETH, but they play completely different roles, and that is why we have separate functions for deposit and then deposit collateral. Okay, now a similar thing would be done for withdrawing collateral. So we're saying function withdraw collateral again. UNT 256 amount, and we make it external. Okay, now this would be similar to what we had done there, a few more extra conditions. Okay, let me just, So it says required amount greater than 0, must withdraw more than 0, then require collateral balances of message.sender greater than equals to amount, otherwise you have an insufficient balance. Okay, now this will be there, but let's just, remove these two and let emit be there and see what we have to add in between. Okay, so we're saying we have to look into how much interest has already occurred. So we will say, borrowed amount is equals to calculate interest occurred, and then for message.sender, because it is giving you the total debt, right? Okay, so now what you do with this is whatever you've borrowed, okay, with that you have to see what is the required collateral, right? Because we said that it would be 75%. So you can only borrow 75% of the collateral. So required collateral will be borrowed amount into, again, 10,000, because we were dealing with basis points there, and then divide by collateral factor basis points. That is how you do it. Okay, now you will put a require condition which says collateral balances of the message.sender, okay, minus the amount, okay, should be greater than equals to required. What is this? Is equals to a required collateral. Okay, because come on, if you withdraw more, whatever balance that you have and what you want to withdraw, if that becomes less than what is the required collateral, then it would break the collateral ratio to the loan that you have borrowed, right? And nobody would want that. So we would say, hey, if this is there, great. Otherwise, withdrawal not possible. It would break collateral ratio, and it has to be a healthy ratio. It has to be, it has to maintain what is the ratio that is required. That is why we don't go about, borrowing more. And then once all of that is done, we say collateral balances of the message dot sender should be minus equals to amount. Great. And then we will make it payable. So we say payable message dot sender dot transfer amount. Great. We have done everything, right? And once you have performed this function, the event can be just emitted just fine, right? So come on, like you locked up some ETH as collateral that gave you the power to borrow from the pool. Now you want to take some of that ETH back. Seems fair, right? It's your money, but well, you can only do that if you are still safe to do so. This function lets users withdraw their collateral, but only if doing so would not put their loan at risk. So that's what we have done there. Make sure that you understand the balance checking. The requirement condition is very simple. The borrowed amount and the required collateral makes sense. What is very important is the require condition, which says collateral balances, because a lot of us would miss out on that safety check or edge case for that matter, right? Now, so we have written deposit, we've written withdraw, we've calculated interest, we've deposited collateral, we have withdrawn collateral. Great. Now I think it's time to write borrow. Yeah, it's already suggesting, but yeah. Okay, so let's just quickly write the borrow function. We're saying function borrow UNT 256 amount, right? And then we say external. So we are checking if the amount is greater than 0. Come on, normal conditions to check. So it must borrow more than 0. Fine, makes sense. We're not looking at how we write it in caps, small, blah blah blah. Then what we would do is we will check how much a balance do we have, right? So we say address this dot balance, okay, is greater than equals to amount. And otherwise we say, hey, I don't think there's enough liquidity, so not enough liquidity in the pool. Okay. Now, okay, great. So these two required conditions work fine for you. Okay. Now we're saying, let's decide on what would be the maximum borrow amount, or let's just calculate it, right? So we're saying whatever is the collateral balances of the message dot sender, and then you multiply that entire thing with collateral factor basis points, and then divide that entire thing by 10,000. Okay. Does that make sense? I mean, if you have logged 2 ETH as collateral and the collateral factor is 75%, so the maximum borrow amount would be 2 ETH into 0.75, which is the collateral basis points, divided by 10,000, because we are taking it as 7,500, and that would be 1.5 ETH. Okay. But that is not where the entire thing stops. It says UNT 256, the current, you will go for the current debt, okay? Any previous debt that you have plus interest that you already owe, right? So we say calculate interest accrued, and then for message dot send. Okay, so this is also coming into consideration that, hey, have we done like enough here? Now, once you've calculated that current debt, we will check if the required, like with the required condition, that is the current debt plus amount less than equals to maximum borrow amount. Otherwise, we say deposit, or in fact, this is confusing. We will say, hey, exceeds allowed borrow amount. right? Fair enough, understandable, right? This is how you're calculating everything. And then once you've done all the check, like if the check fails, the borrow is blocked. But if not, and if you are, if you are at the safe limit, then what would we do? We would say borrow balances for the message dot sender. Okay, we will say whatever you got the current debt plus amount, great. And then we would say last interest accrual timestamp for this message dot sender would be equals to block dot timestamp. Okay, so this user now owes XE, including the past debt, and this is the time we will use to calculate interest moving forward. Quickly, we will say payable message dot sender, okay, dot transfer. Wow, I'm enjoying the musical vibe of it, and transfer the amount, right? And what next? We will just use emit. Did we write anything? Borrow, yeah. User is message dot sender and amount is just the amount, all right? All cool. Okay. Now that we've borrowed, we've talked about depositing into the pool, we've talked about collateral deposition, vagera, vagera. It's time that we talk about function repay. Great. So we say function repay. Okay. Again, we don't need any parameters here, right? We're saying external payable. Okay. Again, I will just get that. I will just write it. Required message or set. Oh, sorry. Value has to be greater than 0. And we write a message must repay positive amount. Okay, great. Then we're saying, hey, what are we repaying, right? So we're saying U into 56. Current debt. Now, how were we calculating the current debt? We were saying calculate interest accrued, and we're saying message dot sender, right? Now, we will also check another that require the current debt is greater than 0. Okay. Otherwise, we'll say, hey, no debt to repay. Great. I mean, come on, this is also an important question. It's not necessary that you're trying to pay or repay only if you had, debt. Might be you were mistaken. So you have to check all of these. And then we'll say, hey, you know what? Let's look into amount to repay. So this amount is basically given as message.value. Okay. Now you will check if amount to repay is greater than current debt. Okay. So we will do amount to repay is equals to current debt, and then what? We will set it here, and then we say, hey, what was I supposed to do again? Oh, yeah. Payable. Okay, let's make the message.sender payable. Say payable message.sender dot transfer. Now we'll show you how. Message.value. Okay, minus current debt. Okay, so this is a point where you refund the extra. Okay, because amount to repay is greater than what you have as the current debt. Okay. Otherwise, we say, and then we say borrow balances for message dot sender equals to current debt minus amount to repay. Fine. And then we're saying what was the last interest accrual time for message dot sender. We're saying it is block dot timestamp. Again, it is going in the else condition. You're out of the loop, and then you say emit repay. What is the relocatable? Repay, and we're saying message dot sender amount to, okay. So this logic is also pretty simple. You are checking a few conditions here. You accept what you have said as, amount to repay is message dot value. Now we need to record how much the user is trying to repay. So sometimes the users send more than they owe, especially if they're not sure how much interest has built up. So we will handle that very gracefully. We will cap the repayment by the debt amount, or at the debt amount. That is what we're doing when we say amount to repay is equals to current debt, and automatically refund the extra. So no need to calculate your debt manually. Just send enough or more, and the contract handles the rest. And then you also update the loan record where you say, hey, the borrow balance is current debt minus amount to repay. So this reduces the user's loan balance and resets the clock on interest accrual. And if they paid everything back, the borrow balance becomes zero, which is like debt free. And then we say fire the repay event. What is the problem here again? Oh, not eternal. We don't want the function to be eternal. We want it to be external. Bad joke. I'm so sorry. Now, if you have written repay, what else do we have left? We've talked about borrow, deposit collateral. I think it's just the utility function that's left. So let's just get it right. Okay. So we will say, hey, you know what? We have already calculated what be the max borrow amount, but I want just a very quick little function that could do that. So we will just say external view returns, right? And uint 256. And we will just, paste what was there. So we will say return collateral, we'll say collateral balances, okay, of the user into collateral factored basis points divided by 10,000. Great. Now, this is how we calculated it here, right? Maximum borrow amount, and that's what we're doing as the utility function. So this function will just calculate how much each the specific user is allowed to borrow. It doesn't care how much they've already borrowed. It just tells you the upper limit of what they could borrow given their collateral. No calculations happening. And yeah, this is super useful for front ends. It lets the UI display, hey, you can borrow up to 3, or shows a progress bar of how much their borrowing power they have used. Now, we will say, I also want to get, what is the total liquidity that is available, which is basically the address of the balance, like the wallet. Okay. So we're saying external view returns uint 256, and we say, hey, it's time you this dot balance. Okay, now what happens? It's basically even more simpler. This will just tell how much ETH the lending pool currently holds, because you cannot, borrow more than what is already there in the lending pool. So front ends can use this to show the total pool size, indicate whether there's enough liquidity for a borrow request, warn users if the pool is running low on funds, right? So we will just, we are done. So we will just compile the simple lending.sol. We will come here and we will deploy it for the first time. I think after many days, we don't have a constructor. We don't have anything, any value to give while, deployment. Okay. So what is interest rate points? 500. Again, that's 5%. Total liquidity right now, 0. Collateral factor basis points, 500. Now I want to deposit something, right? So I will say, hey, let me just deposit 10 Ether. Deposit. Great. Fine. Now, there's a deposit collateral section, right? But let me show you, like, these are simple functions, right? Deposit of the balance. It's 10, right? Get maximum borrowed amount. Right now, it's 0 because we are not dealing anything with depositing. Right now, the liquidity pool is 10. Now, let me deposit some collateral. So I will say collateral would be 8. Okay, deposit collateral. Okay, great. Now can you check get maximum? So you can maximum deposit 75% of it, which is 75 by 100 into 8. So it would be 6 ETH, right? And I want to check borrow balance, it's 0. Calculate interest, 0. Collateral balance, so everything, the collateral balance is 8. Now, if I want to borrow, I will say, let me just borrow. Instead of 6 ETH, maybe I would like to borrow, because 6 is the maximum allowed amount, right? So I would say, let me just borrow 4 ETH, right? Now, can I check what is the collateral balance? Calculate interest. Okay, so with whatever timestamp the borrow balance is 4, and there is something withdraw, right? Now I want to withdraw collateral. Now I know that there's 2 ETH still left for me, and 6 was the maximum, but let me just try if, I can withdraw. Oh, shit. I withdraw it here. No. I wanted to withdraw the collateral. Right? And it said withdraw not possible. It would break the collateral ratio. But if you want 2 ETH back, you will get it. Like, let me just show you here. If I do this, you will just get it. Right? So here there's a deduction. So, last interest for the address. Again, it's happening in timestamps, and yeah, that is a timestamp that you have. Now I want to repay. Okay. Oh, we must repay a positive amount, right? So let me see. That is collateral. Get total liquidity. We have 8 ETH right now, and okay, we have borrowed. Okay, so with this interest accrued, I think this is the entire thing that we have to pay, but I just want to pay like 2 ETH. That's all I can afford right now. So I will just repay 2 ETH. Okay, great. Now I would say deposit balance is at 6. Borrow balances. Now this is left, right? Because I had deposited, I borrowed 4 ETH and I deposited 2 with the last repay, and this is with the interest. So yeah, I mean, now that I have this, if I check it again, okay, great. Now if I do like 3 ETH, here I have 10 ETH, and I just say, hey, I want to deposit 3 ETH and repay entire thing. Now, if you check the borrow balance, it's 0, right? And you also get some of it back. And that is what was happening here when we said, hey, amount to repay, just set the maximum cap as current debt, and then you will get the rest of the ETH back. So yeah, that's pretty much it for day 23. I absolutely love the contract with such cute little simple calculation, but doing so much on the DeFi side, although DeFi gets complicated over time, but then it's always fun to, do all of this. So you had just created a fully functional lending pool, accept deposits, let users lock collateral, borrow ETH, accrue interest over time, and also lets users repay and reclaim collateral. So this was more of the core mechanics of DeFi lending, and you should definitely check out Aave, Compound, Uniswap, and all of that. And yeah, that's it. I will see you on day 24. Till then, keep building, guys.